I'm very lucky to get questions from colleagues. I'm honored by it, and I thank them for the opportunity to answer their questions. From time to time, I'm going to feature questions that I get from them if they provide for teachable concepts that I can relate to you in these vlogs and also on our blog at www.thetruthaboutsforensicscience.com. This question is from a colleague and provides for just such an opportunity. Here's the question. Hey Justin, I have a DUI case where the lab did an analysis by headspace gas chromatography, and it turned out a result of 0.10 BAC. He is involved in an industry where he's occupationally exposed to ethanol all day long, as well as other chemicals and volatile organic compounds. Despite the fact that OSHA requirements call for him to use a respirator, he doesn't. After a long day working but not using the respirator, he had some beers. We verified this by a point of sale records, video from the bar, and independent witnesses that have nothing to do with him. But the amount that he drank was nowhere near enough pharmacologically to get him up anywhere nearby a 0.10 BAC. I was finally able to get the discovery after getting a judge to sign a motion to compel, and I was looking at the data. In the data within the run, there was no separation or resolution matrix and no calibrators. I was confused, so I called the lab. They sent me some more data. They told me that the lab had a policy of only doing a calibration curve once a month or so and running a separation or resolution matrix of 5 molecules twice a year when the state sent them proficiency tests. This doesn't sound right, does it? Or is it? Are there any resources such as peer-reviewed studies or treatises that specifically says that what they're doing there is wrong? In our sister blog, we wrote and answered this in part, a blog post about the lack of standards in forensic science community. See generally a Pennsylvania DUI blog post entitled, Why Forensic Science Testing for DUI BAC Determination is a Silly Sister of Analytical Science and the Concept of Good Laboratory Practices. And again, we wrote, a large problem in gas chromatography, no uniform standards for GC run position or composition. So we are really in an unusual position, as there are no standards in the community that we can point to that were violated. It's like the Wild Wild West. However, there are 3 basic issues that jump out to me as potential issues with this method, and they're as follows. Number 1, qualitative measurement validity issues. Number 2, quantitative measurement validity issues, and 3, the true source of the ETOH or ethanol measure. Number 1, a very basic benefit and feature of gas chromatography is its power to resolve and its potential power to be specific and not merely selective. The difference between a test being merely selective and being truly specific would be the following example. If a test is selective, then it can tell the difference between compounds, but not specifically or uniquely. For example, enzymatic assay, otherwise known as hospital blood, is selective in that it reacts to ETOH, but also reacts similarly to lactate and isopropanol. And there are also many more compounds it reacts to. So in the case of enzymatic assay, if you have a sample with lactate, isopropanol, ETOH, or other things, the method cannot tell you the difference. It reports all of those present in whatever amount together as ETOH. This is a selective test. It is far from specific. This is in part why enzymatic assays are not forensically defensible. See our blog post titled, WellSpan is to be commended, but why people who have been convicted for decades of DUI should be upset. A specific test is one that can provide for uniqueness in the qualitative result, meaning that the result reported from that specific compound alone and to the absolute exclusion of everything else in the universe. It is definitely ETOH and nothing else, meaning no lactate, isopropanol, and it's just ETOH as to the result. If designed and performed perfectly, meaning headspace gas chromatography with flame ionization detector, it has the potential to provide a unique qualitative measure, meaning what compound we have to the exclusion of everything else in the universe. And then, if and only if we can separate, do we have the potential to achieve a quantitative measure, answering the question, how much do we have? The GC itself is a qualitative analytical method whereby, if it alone is used, it can only tell that the characteristic is present by the retention time as compared against the known. At best, using only a GC, you can tell the suspect analyte is consistent with characteristics of the known. It does not necessarily mean that it is the analyte until you have a detector of some sort of supreme analytical sensitivity, such as time of flight or mass spectrometry. If we cannot master the first prerequisite of obtaining a valid result, which is separation, then we cannot validly quantitate. Therefore, it's all about separation, the chromatography. Separation, separation, separation. Separation must be proven. It must be demonstrated within each batch, which is the group that comprises the run, which includes typically the knowns, such as the controls, and the unknowns, such as the accused DUI driver's blood. On the day and within the run that contains the accused motorist result, it must be proven. In an ideal world, we would demand that everything that that person comes into contact with, or may be in his or her blood system, be proven to be separated from ETOH. If separation is not proven on the day and within the run to include all substances that may be in that person's blood, then we violate all of the requirements of gas chromatography. Separation first. Without separation, we cannot validly quantitate. We fail. Separation is proven by using CRMs or certified reference materials in the manner outlined in our post entitled, "If he was an analytical chemist or a DUI defense attorney, he would say, 'Show me the separation.'" In this example from my colleague, according to laboratory protocol, we have attempts to prove separation, but it's of an inferior quality because it is only proof separation if there's good resolution and good separation between methanol, ethanol, isopropanol, acetone, and N-propanol. These are only 5 compounds out of the 65 million registered with the Chemical Abstract Service Registration Service. Not that we should require or demand all 65 million be separated by the assay, but the most common ones should be. This should include environmental exposure to other compounds, such as in this hypothetical case, and whatever was used to perform the cleansing of the ETOH from these, then how can we exclude the possibility that the peak on the chromatogram is not unique to that compound and is not due to the contribution of some other compound? Remember, selective versus specific. Remember, proven separation first, and if and only if separation is proven do we move on to quantification. If separation has not been proven on your day and within your batch, and if, for example, all of these chromatograms where resolution matrix or separation matrix were from different dates other than the date of the analysis of your driver's unknown, this is violative of best practices in terms of good laboratory practices in the regulated world, such as the EPA and FDA. So they have not proven separation on the day within the batch of the analysis of your unknown. The absolute most they can scientifically say is that they are presuming so. They have no data to support this conclusion on the day and time that the testing of your unknown, your motorist's unknown, under the chromatographic conditions that your person's test was run on, that they can prove and show separation. This is especially so when they cannot show separation of all matters that may be in the blood, such as environmental exposure to VOCs. Remember, there should be no presumptions in science. In the courtroom, by law, there is but one presumption. That is not that the laboratory could prove separation based on what they did at some perhaps irrelevant compounds at some irrelevant time before or after, but that of the presumption of innocence. A headspace gas chromatography flame ionization machine does not know what it's examining straight out of the box in terms of the qualitative measure, or how much it's measuring straight out of the box in terms of the quantitative measure. And it must come from the vendor in an untrained way. It has to be trained or taught. The first part of teaching it what it's examining, meaning the qualitative measure, is done through the it is examining, is called calibration. We can tell how much in terms of quantification only after we separate. I know I'm beating a dead horse, but I need to impress upon you separation first. Quantitation is achieved through establishing a calibration curve. Without demonstrated and proven calibration curve as to both the target analysis or analate, ETOH, and the internal standard, typically N-propanol, then you absolutely cannot quantitate validly. More on the importance and the nature of calibration curves can be found in our blog post entitled, "When is a straight line a curve, a calibration curve?" and quote, "How do they make a squiggly line turn into a magic number, area under the peak?" Go look for those blog posts. If quantification has not been proven on your day and within your batch, and if, for example, all of these chromatograms and the resultant calibration curves were from dates other than the date of the analysis of your particular motorist unknown, this is violative of best practices in terms of good laboratory practices and the regulated world such as EPA and FDA. So they have not proven quantitation on the day and within the batch of the analysis of your unknown. The absolute most they can scientifically say is that they are presuming so. They have no data to support the conclusion that on the day and the time of the testing of your unknown and under the chromatographic conditions that your person's test was run on, that they can prove and show proper quantitation. Remember, there should be no presumptions in science. In the courtroom, by law, there is but one presumption. That's not that the laboratory could prove quantitation because they did so at some irrelevant time before or after, but that of the presumption of innocence. Let's talk about source issues. As much as I love headspace gas chromatography with flame ionization detector, there's a big limitation as to that particular method and that instrumentation. It is crucial to note that even the most perfect method and the most perfect analysis by the most perfect laboratory on the most perfect machine cannot determine the unique source of the result. Any test that's performed is only as good as the sample. Even if the laboratory does the mythical perfect analysis, if the sample is not representative of the true condition of the blood as it was flowing through the person, then the reported result can never be correct, meaning true. Put more simply, garbage in equals garbage out. What I mean by that is that laboratories work in the garbage in, garbage out principle. There's some more information on the garbage in, garbage out principle in our blog post entitled Retesting Blood Alcohol Results. Please go look at that. It is the difference between endogenous, meaning that which is your client's fault from consumption and existed in the tube at the time of text collection in terms of ETOH, and exogenous, that which is from outside the natural organic state as it flowed through the person's veins. ETOH contribution from sources such as environmental pre-exposure of some substance